Part 3. Laws of Logarithms. In grade 9 math, the exponent laws were introduced. We had the product law, which of course when you multiply two things with the same base, we would add the exponents. Ooh, that's just a mess. Let's try that again. A to the x times a to the y equals a to the x plus y. Quotient law. You divide two things with the same base, subtract the exponents. So a to the x divided by a to the y equals a to the x minus y. And the power law. When you have a to the x all to the y, multiply the exponents. So that's a to the xy. Okay. Good. So I'm going to show a proof and how those exponent laws can be used to create the logarithm laws. You don't have to memorize this process, but you should watch to see how this is accomplished. Okay, so product law of multiplication. Just remember that all of these log laws are on your formula sheet. Okay? So log base b of m times n equals log base b of m plus log base b of n. So I'm going to let x equal log base b of m, and y is going to equal log base b of n. All right, so if I convert those into exponential form, that's b to the x equals m, and b to the y equals n. Now, let's multiply them together. So that becomes b to the x times b to the y. Well, remember, b to the x is m, and b to the y is n. So that's the same as m times n. Now, back to our exponent laws. When I multiply two things with the same base, I'm going to add the exponents. So that becomes b to the x plus y equals m times n. Now, I'm going to convert that back into logarithmic form. So that is log base b of m times n equals x plus y. But if you remember, x is log base b of m, and y is log base b of n. And you see, log base b of m times n is the same as log base b of m plus log base b of n. So if you had something like log base 3 of 6 times 4, I could rewrite that as log 3 plus log base 3 of 6 plus log base 3 of 4. That's how that works. Okay? All right. Quotient law. Same thing. I'm going to let x equal log base b of m, and y is going to equal log base b of n. So same as before, b to the x equals m, and b to the y equals n. So we have, we're going to divide them. So b to the x over b to the y is equal to m over n. Okay, right? Because b to the x is m, b to the y is n. Okay, and then we're going to subtract our exponents. So that becomes b to the x minus y equals m over n. Okay, I'm going to take the log of both sides. Convert it into logarithmic form because now it's an exponential. So that's log base b of m divided by n equals x minus y. We're going to sub in for x and y. X, of course, is log base b of m, and y is log base b of n. So log base b of m divided by n equals log base b of m minus log base b of n. Good, and our formula is proven. All right, let's move on to the power law. So we're going to let x equal log base b of m, okay? And again, we're going to convert that into exponential form. So that becomes b to the x equals m, okay? Now I'm going to put both of them to the power of n, okay? So then that becomes, again, we multiply the exponents using the power law. So b to the power of xn equals m to the power of n. I'm going to convert that now into logarithmic form. So that becomes log base b of m to the n equals x times n. But x, of course, is log base b of m. So remember multiplication, I can write them in whatever order I wish. So I'm actually going to put the n up front, and then x is log base b of m. So that's log base b of m to the n equals n log base b of m. Got it. All right, last one. Now you've kind of been working with this formula a little bit in the previous sections. So again, I'm just going to prove that it works. I'm going to let log base b of c equal x. So I'm going to convert that into exponential form. So that's b to the x equals c. Okay. I'm going to then take the log of both sides. So that becomes log of b to the x equals log of c. And from the previous formula, I know I can take this guy and bring it down front, because that's what this formula is. N is here, and then n is in the front there. So I can rewrite that as x log b equals log c. And then to get x alone, because that's x times log b, I'm going to divide both sides, that's a b, by log b. So then x is equal to log of, I forgot to put my a in there. Okay, get out of there, auto-saved. Okay, good. So that becomes log base a of c over log base a of b. Now, technically a can be anything that's a value, like could be 10 or could be e or whatever, okay? As long as it's a is greater than 0 and a does not equal 1, okay? All right, so that's the proof of all the log laws that are on your formula sheet. Now we're going to use them to simplify. Okay, so bunch of examples and then you can get to work. Expand each expression. So what that means is to use our log laws. Log base b of a times c. So again, if you notice, this is multiplication. So that means that we're going to use our log law for multiplication. So that's going to become log base b of a plus log base b of c. Okay, and now it's been made bigger, so it's an expansion. Looking at the next one, log base b of 5 over x. This is a quotient because it's division. So we're going to use our log law of subtraction. So that becomes log base b of 5 minus log base b of x. Okay, good. Part C, I have 4 times y squared divided by z cubed. So we can use a few log laws here. Okay, so that becomes log of 4. And our base, of course, is 10, so I don't have to write it. Log of y squared, okay, because again, 4 times y squared, that becomes plus. And when we divide, that becomes subtract, so minus log of z cubed. Now, we can use the other log law. Remember, we have log base b of m to the n. We can bring that n down front. Notice that it's only m to the n, not the whole thing. Log base b of m all to the n. That one it doesn't work for, okay? It only works when my value is to an exponent, not here. So don't use it when this goes on. We do have that situation here and here, though. So let's write that as log of 4 plus 2 log of y minus 3 log of z. Nice. Number 2. Rewrite each expression as a simplified single logarithm. Answers should be written with positive exponents. Okay, so if you notice, the first thing you should do is check to see that they have the same base. In this case, they both have a base of 4, so we can use our log laws. So that becomes log base 4. Because this is adding, I will take my values and multiply them. So that becomes log base 4 of 21. Okay, good. Notice again I have ln, so I have log base e's. So I can use a log law. So that becomes ln, and I'm subtracting, so that turns into division. Ln of 10 divided by x. Now, number 3, evaluate each expression. In the previous section, we did something like log base 6 of 216. That I could evaluate because 216 was a power of 6. Looking at this question, 48 is not a power of 2, neither is 3. So I can use a log law to simplify first and then seeing if I can divide or calculate that out. So if you notice, they both again have the same base. They're log base 2. So I can write them as a single log base 2 of 48 minus 3. So that would be changed into division. So that's 48 divided by 3 using our log law. Okay. Now I can simplify that as log base 2. 48 divided by 3 is 16. 16 is a power 4. That's log base 2 of 2 to the 4th. And again, we can use our power law to bring that 4 down front. So that becomes 4 log base 2 of 2. Log base 2 of 2, remember, is the same thing as if you went log 2 divided by log 2, which of course just equals 1 because you're dividing something by itself. So that guy just becomes a 1. 4 times 1 is just 4. Good, and you can always check by typing that onto your calculator. Part B. So, again, first thing we should check is see log base 3, log base 3, log base 3. Awesome. Now, if they have a coefficient like this one has a 2 and this one has a 1/5, we're actually going to take care of that first. So, 2, remember that becomes an exponent reversely using the power law. So that becomes log base 3 of 6 squared plus log base 3 of 0.75 plus log base 3 of 243 to the power of 1/5. Because again, the 1/5 becomes the exponent here. Okay, now I can use a log law because I have all the same bases. So that becomes log base 3 of 6 squared is 36 times 0.75 times the 5th root of 243, because remember 243 to the power of 1/5 is the same as the 5th root of 243. So if you want to find the 5th root of 243, you should find that it equals 3. Okay, awesome. So that's log base 3. Now you can multiply all those guys together. So 3/4 of 36 is 27. 27 times 3 is 81. We also know that 81 is a power of 3. That's the same as log base 3 of 3 to the 4th. We can bring the 4 down front. So that becomes 4 log base 3 of 3. And again, log base 3 of 3, just like log base 2 of 2. Okay, that equals 1. So that becomes 4 times 1. And this question also equals 4. Okay, great. There's lots of good practice on page 446. Please make sure you work through that. Again, because the only way you're going to get good at these log laws is to practice them. Good luck and show your teacher when you're done.